I'm Liz, and actually it's my great honor to present my work here. Yeah, those are actually some ongoing work also. Today I'm going to talk a bit about the proactiveness of conversational search and recommendation. So as we all know, search and the recommendation systems are actually everywhere. Starting from the morning, we get out of bed, we check the social media feeds and also some newspaper, right? And when we are working, we might check the Google and the archive to search some like new concepts when we are not so sure. And after work, we might need to find some restaurant and grab some food. And then we may use like Foodpanda or Grab. Those are some local companies. And then after that, we might still need to go some online shopping, like using Shopee, Amazon, right? So basically, all of those concepts that we see on those platforms are actually ranked or selected by search systems or recommendation systems over millions or billions of information items. And in fact, even when we are looking for jobs or like taking courses, those items is still given us by some like search and recommendation systems. So those systems actually are very useful, and they help us to kind of overcome the information overload problem. And now let's look at some typical search and recommendation systems. So this is a typical search system, right? User have some information needs, and then we may formulate a query and give to the search engine. Search engine take those queries and then rank over the information items and then present us the results. Right? So this is a typical search system. What does it does? And then let me make it more concrete, right? Suppose we have this, we want to buy this kind of short for a little girl. We may formulate a query like ruffle peplum top without sleeve for little girl, right? And then we give to some search systems, and then the system give us some results like this, right? However, suppose the system doesn't give us the target, then we might need to reformulate our query and do it again and again and again until the system give us the result, or we will simply quit, right? So this is a typical search system does. And then let's look at some typical recommendation system. What does it does? So for a typical recommendation system, the user might visit some like app or some websites, and then we have some rating information, the clicks, the visits. Those information logs are all stored in some kind of like database, and those are saved as records. And then when the user visits the system again, then the recommender, we are looking at those preferences, right? Guess the user's preference and then return us a list of items to the user. So this is a recommendation system. How does it do? So still the same example, right? Suppose we want to buy this thing. Basically the system, we are looking at those history over the system kept, and then give some ranking and then push those items to the user. So this is how a recommendation system gives us those results. And then why we need a conversation, right? So basically in search and the recommend, search system, the user takes the initiative, which means the user is more kind of active, taking control of the whole process. And then the user pull information from the search engine, while for recommenders, the system takes the initiative. So it's kind of the recommender push the item to the user. So actually, both of system got some problems, right? So you see, those information actually is a kind of unidirectional. And also because it is unidirectional, sometimes the ambiguities happens. So sometimes the user is struggling, what should be the right query, right? In order to find the item. And then for recommenders is many of the times the system is struggling to find the correct preference. Right? So this is this kind of problem happens in those two kinds of systems. And this is why we need conversation. Suppose the same scenario, right? The user still want this thing. And if there's some interaction interface, like using conversation or even using some images, then the system can more accurately get the preference of the user and then interact with the system. For example, when the system is not so sure about the user's requirement, then maybe it can just reply too many choices and then ask for more information, right? And then the user can gradually give more kind of requirements and then refine the system return, right? Where it is more sure, then can return us some results. So this is how the conversation plays in this kind of interaction. And then let's look at a brief history of the conversation systems if we want to bring those conversation techniques into the search and the recommendation. So basically, this one gives us a very brief history of conversations agents, right? Starts from the 1966, which is the MIT that built the first ELIZA, the conversational agents. And nowadays we have ChatGPT and Google Lambda, Google Bart, Ernie Bot, which is supposed to build by Baidu, right? So basically we have kind of 3 stages. And then the trend actually is kind of going up very quickly these days. You see, in the early days, it's more like a rule-based systems, right? The user can give some utterance to the system, and then the system can find some patterns and then transform the input into some kind of a response, mostly by using some rules. And then later in this kind of area, more machine learning algorithms are built. Then in like 2016 and 2019, we see a lot of smart assistants, right? Like Google Personal Assistant, Amazon Alexa, Tianmao Jingling. So those systems are actually very popular in this kind of era. And then almost the same time, the transformer comes out. Then the large-scale models starts to kind of bloom up all the process. You see Tesla bot and also this kind of Google Lambda. Actually, it's just last year, December, right? The ChatGPT came out, and now every day we see a lot of news regarding those systems. So actually, when we taking a look, even now the ChatGPT comes out, but still there are some kind of open problems there. For example, how to make those systems more proactive, right? It's like, for example, the ChatGPT nowadays, even when we're talking to the ChatGPT, when we give some utterance, then the ChatGPT is more kind of like passively answer our questions, right? Suppose the ChatGPT can do some other things, be more proactive, right? Then it might be even better. So here we do kind of some explorations over the proactiveness of those conversation agents. And I just list those 3, but actually there are more. So today we're only talking about those 3. So for example, first one, handling the unseen. Remember when we're talking about ChatGPT, some people say the training data actually stops at like 2021 sometime, right? Then the things happened after that time, then the ChatGPT cannot answer. So this one, handling the unseen, actually is a very critical point. And also driving the conversation. When we're talking with the chatbot, sometimes we hope the system can also be kind of more active, like taking the control. Later we'll be talking about a little bit about this. And also response control with human feedback. So actually conversation is an interactive process. During the process, how do we kind of modulate our conversation during the process given the user feedback? It's kind of kind of adjust our kind of attitude or direction during the process. So it's kind of, we can refine the response by the immediate user feedback we obtain. So those are the brief topics I will cover today. Some of them we give more details about. Due to the time limitation, some of them we just briefly go through. Yeah. So first of all, handling the unseen. So existing task-oriented dialogue systems, usually we will have a ontology. So what does that mean? Usually we have a list of prefixed intents, and also we have some prefixed slots given some, the slots can take some specific values. For example, like this one, find a good eating place for Chinese food. So the current system, what they do, usually they will first take this utterance and then use intent classification. So basically it's a classification task. Classify it into some existing intents. So first we give the intent, and then we kind of use some sequence labeling techniques, and then give some slots and find some values from here. And then we combine those two, given the intent and the slot values, then we kind of transform into like structured representation. Find the restaurant where rating is good, type is Chinese. So this is currently what the system do here. But however, right, suppose we can build those systems using those existing techniques. Then suppose here we build a restaurant booking agents, and then we deploy it. And then suddenly something happened, right? Such as the COVID-19 comes on, then a lot of new situations will happen. Then how to handle this kind of conversation, right? Such as, can you show me your vaccination QR code to me, right? A restaurant booking agents ask something like this. Or maybe, can you book a table for me in Suntec? Some new places happen, right? Then how to handle those. So those are the important things. When we deploy the conversation system, how to find some new intents, new values, or even some new slots. Actually, there are some work doing this. Some of the works discovered just from scratch. So it's kind of, we have a lot of conversation data, and then how to find the intents from there. So this one is actually very representative. It's not just about this paper. A lot of paper work discovered from scratch is kind of follow this pipeline, right? Unlabel the data and do some feature extraction, and then use some encoder to encode it, and then do some feature assembly, and then important thing, do clustering. And then the clustering results is finally used as the intent label or just as a heuristic to help annotation. So this is kind of a common pipeline. And then they have some shortages. So first of all, right, heavily rely on manually designed features. This is one thing. And also, usually if we want to train a neural network model, we might need large data size to train the good network parameters. And also, because here use the clustering results, sometimes it's hard to produce the intents in like different granularities. So then, besides this, some work starts to do something like different. You see this scenario is the same as I just mentioned before. We have a lot of corpus, right? And then we want to find those intents. Another scenario is, suppose I have some of those data. I already built a system. So which means I have the data and also some observed intents. Then sometimes some new intents happen. How do we find those new things out of those existing things, right? Such as, can you help me link this card to my Google Pay? This is an unknown intent, which is not inside those observed intents. Then how do we do this? Obvious way is we may use some supervised learning methods, right? So those methods are already there. Then actually two essential questions need to answer. First is how to better cluster the utterances in order to kind of propagate the non-image from the non-knowledge from those labeled data to those unlabeled data. Another question is how to learn semantic utterance representations to provide proper evidence for the clustering to get better results. So those two aspects, actually there are a lot of works following those two tracks. I just give a very representative one here. So for example, this one just use aligned clustering. So what does it mean here? Suppose I have some labeled data and also some those gray ones are unlabeled. I will not go into details. I just introduce the general idea is they can use those labeled data to train a transformer using the label. Then they have a feature extractor. So for all the instances, they can extract the features. So which means every node here is kind of represented as a vector. And then after that, they rely on those feature vectors to predict a case. Suppose they predict that there are 3 intents, right? The formal only like 2 intents here. They predict there are 3 intents. Then they use the k equals to 3 to apply the k-means. Then they get those pseudo labels. And then they use those pseudo labels to train the model again. And then after they train the model again, it's kind of updated the feature extractor. They reapply it and then extract the feature for those again, and then do k-means again. So the same one problem here is how to align those different clusters, right? Because the first time I have this kind of cluster assignment, after I train with the pseudo label, then the cluster might change a little bit. I mean, the cluster assignment. So this is the essential part here. They align those cluster level, they align those clusters to make the process like a gradually kind of move towards the real intents they have. So this is kind of the important component here. They use the cluster information, get this kind of global patterns, and then propagate to those unlabeled data. So this is about clustering. Actually, there are more. So if interested, we actually provide a tutorial. Then you can go through it. There are more papers introduced there. And the second thing is how to learn semantic utterance representations to provide a better evidence. So this one also we have a lot. I just introduced a very representative one here, right? For example, we can directly apply some vanilla pre-trained models to extract the feature, right? This is one thing. But however, we might expect that this is not so good. And then another thing is beyond those pre-trained language model, we further do some fine-tune using those labeled utterance with some non-intent, right? So this one also can do, but the problem is we need a lot of labeled data to do this. So in this, which means those two are not optimal. And then there is a work doing some multitask pre-training using external data and internal data. So the idea is beyond the data set they have, they actually find some other public intent data set and make use of it. So this one helped them to do some pre-training. And then over this data, they have some labeled one and also some unlabeled one. But never mind, for unlabeled one, they use mass language model to pre-train. And with labeled one, they use the label to do cross entropy loss. So it's kind of using some outside data and the data itself to do some multitask pre-training. And then after that, they do a bit of contrastive learning with some nearest neighbors. So by doing this, the model gets like kind of better performance. Yeah, so here is something about contrastive learning. So for each labeled node, it will get some neighbors for it and treat those neighbors as some positive samples inside the contrastive learning loss. So that is for new intent discovery. We also have kind of new slot discovery. So which still we have the restaurant bot, suppose. And before we have some ontology, right? We have this kind of price range slot, which can take value at expensive, moderate price, the cheap, blah, blah, blah. And also we can have area, and then which can take the value of east, north, west, south. So a lot of candidates. But still, when new situations come, we might need some new slots, such as vaccination dosage and vaccination status, for example. So how do we find, or say, how do we detect those new slots together with its value from those utterances? So this is another scenario we might need to consider. So here I also introduced two scenarios. One is detect from the very beginning. Basically, you don't need to look through those figures very detailed. The basic idea is they can kind of using some NLP, natural language processing tools, such as frame semantic parsing, syntactic dependency parsing, name entity recognition, frame parser. So a lot of tools there, and then we apply those tools into those utterances, right? Then we can get some labeled data like some span here, and then get a class like origin, locale, expensiveness. And then we make use of those information and help us to get those slots. But here, you see those works are all like in this kind of relatively early years. And then the critical part here is we need to do a lot of ranking and merging in order to get the slots. So here, the manual process needs human intervention and largely affects the final results. And also, instead of entirely without label data, sometimes we usually have some access to a small amount of label data in real practice. So that is why there are some works just apply some out of distribution detection algorithms to do this. So here, basically, I just give a very brief overview here. Suppose we have an utterance, right? We can encode it and then treat it as a sequence labeling task using some labeled data, right? In domain slot types to label it. And then after we train this model, for those unlabeled data, we can still apply the encoder, and then we use some like a maximum softmax probability algorithms or Gaussian discriminant analysis algorithms to detect those out of distribution intents. And then finally, we get some novel slot types. So there are more other kinds of algorithms, but this is a kind of general idea here. But still, for new intent, new slot discovery, we have a lot of open problems that haven't got people to work on it yet. For example, early detection of new intents or slots. So existing works are all based on some static data. Those intents or say the slots are already there. We sure they are there, and the amount is not small. But however, if we really deploy a conversation system to the public, then early detection is actually a very critical problem, right? In order to kind of reduce the human unsatisfaction. And also how to effectively integrate human feedback. So this is because if we totally rely on automatic algorithms, sometimes the result we get might not be so reliable. So instead of totally rely on those algorithms, sometimes we might provide some human annotation efforts. Then how to integrate those human feedback effectively is also another critical thing we might need to looking at, such as using some active learning algorithms. So this one also can still need some attention. And also how to balance with some existing slot structure. So suppose we have a slot structure already there, how do we find those new ones that can still balance with some existing ones? So how to balance the whole structure? And is there any other better internal state representation? So this is one is actually a very kind of critical question. So instead of just using some slots and with values, or another way is directly get end-to-end modeling. So everything is encoded as a vector. Is there any other better internal state representation? So we still need to think more about this. So then we go to the second part, driving the conversation. So I just give a very quick example here. So usually when we talk to the chatbot, we usually categorize as open chatbot or task granted one, right? So however, there might be something between. Suppose the bot actually chat with us like an open chatbot, but the agent also have some target in mind. Then how does this work? I mean, from the perspective of those companies, they might very favor this kind of bot, right? They want to sell you something, but at the beginning, they just talk with you like a free chat. So you see, for those kind of bots, actually a lot of important things we need to tackle, such as how to ask clarification questions, how to suggest some useful questions in search, how to mix those chit-chat with task-oriented interactions seamlessly, and also do a little bit of mixed initiative in the control flow. So which means not only the user control the flow, sometimes the agent can also control the flow and do a little bit of topic shifting, right? So how to, those are actually are all kind of open questions. So I give you some examples, right, regarding the initiative in the chatbot, who takes the control. So we have a definition of the initiative in conversational agents. Actually, we can categorize into like 5 levels. The first one is kind of very lowest, right? The user say, do you like dogs? Just answer yes. What is your favorite animal? I'm not sure. So less information are provided here. Sometimes it's very hard to continue the conversation, right? And then we have a relatively low level. So what is your favorite animal? It says dogs. Still get some information, but not too much. Do you like the dogs? What do you like about dogs? They are friendly. So still a little bit hard to still continue. And then we have the medium level. For example, this one. What's your favorite animal? I love dogs. I want to get a golden retriever. So something about golden retriever can be continued, right? So it's kind of getting more information. And then have high ones. What's your favorite animal? I love dogs. What about you? So it's starting asking you the information to encourage the conversation continue. And also, what's your favorite animal? Dogs. Let's talk about golden retrievers. So it's kind of adjust the topic already. And then we also have an abrupt level. So which is, what's your favorite color? Talk me about the dogs. It's directly change the topic. Sometimes might be a little bit rude. And for example, what's your favorite animal? This is boring. I want to talk about something else. So they are abrupt kind of interaction. So actually we have more example regarding those 5 levels, right? For the non, this one is sometimes it's yes, no response to some binary questions, uninformative, right? And then for low levels, it's usually response to some close-ended questions and without extra information. And then for medium level, can respond to some open-ended question and responses that share unprompted information. Sometimes get some new sources here. And then high level, you see a lot of questions involved here. And also we have some commanding, requesting a topic naturally. So here naturally is very important. And then for those abrupt ones, sometimes it's just commanding, requesting a topic unnaturally. And sometimes it's about some complaints. So you see across all the 5 levels, question is actually a very important thing here in doing the initiative. So here, there are some ongoing work about those learning to ask. So actually learning to ask can be conceptualized in like 3 aspects, right? About the input, most of the time it's about text. And also we still can input some image, suppose it's a multimodal conversation. And the knowledge is also important for those kind of conversation. And then the focus of learning to ask, actually 3 important things. When to ask, right? What is a proper time to ask question, what to ask and how to ask. And then regarding cognitive level, is from the low level to higher level. And regarding when to ask, actually in e-commerce search queries, I mean the search sessions, sometimes nowadays the conversation recommendation systems usually is kind of when you go into the system, they directly ask you a question and cannot stop. Just ask you a question and you answer the question and until you find the item. So it's kind of less natural. Then actually another more natural scenario is allow the user to browse for a while and only ask when it is needed, right? So this is in this kind of scenario is you need to properly decide when to ask and ask what, right? And also how to ask. And you see this kind of system this is really work in 2021. Is learning to ask in conversational recommendation systems, right? The system might be not so sure when at the early stage, especially. And in order to avoid generating some poor responses, sometimes the agent can ask a question, right? For example, the user say, could you please recommend me a movie? Then this one might be hard to recommend. Then the agent can say, what's your preference on the genre of the movie to get more information. And so that's why it's learning to ask. Another thing is about target driven. So for this kind of topic, actually already got many works working on it, right? Given the target ebook, then it chat with the user until the ebook really happens in the conversation. So this one, I introduced one of the work, actually the very beginning, the first work, and later there are some works continue. So This one is basically given a target, and the user chat with the user, the agent chat with the user. And then in this work, it's actually 2 levels. One is about turn level keyword transition. Another is the discourse level target guided strategy. So what does this mean? Basically, given the conversation history and the target, the discourse level target guided strategy will kind of find a kind of path to go, right? How to guide this from basketball to the final dance, right? Basketball to dance, how to move to it. And then the turn level keyword transition is kind of ranking all the kind of keywords and then select one. And given this selected keyword and the context, it will do some response retrieval and retrieve some response and then use those response treated as the real response. So it's kind of using those keywords to guide the conversation, right? You from the basketball, jump to music, and then music, maybe jump to dance. This kind of path. Now, actually, there are more works about this, right? This is the first one in SEO 2019, right? Using turn level keywords transition and discourse level target guided strategy. And then after that, the people start to looking at using graphs to improve the smoothness of the topic transition. And then even further, there are people kind of doing kind of more than one topic transition. Before it's just one topic. And then when people extend it, they can do kind of multiple topic transition at the same time. So if you're interested, can go to these papers to looking for more detail. And then that is for driving the conversation. A lot of open things we can do over that. And then another thing is response control with human feedback. So due to time limit, I just very briefly go through it. So this one, what does it mean? Interaction, I mean, conversation is the interaction process. It's not like some static corpus there, and then we just finding some patterns and then get the prediction. Actually, during the interaction, a lot of information or say signals we can get. For example, how to learn those signals, I mean, autonomously from user-system interactions. For example, if we interact with the user, sometimes the system, I mean, when we interact with the user, if the user kind of barge in, usually means our answer is interesting and kind of informative, right? If the user kind of do a bit of reformulation, which means our answer is not expected. It's kind of the user need to ask again and reformulate. So a lot of feedbacks actually should be leveraged. Explicit feedback is easy, right? Did I answer your question? Yes. So this is a kind of a direct thing. Actually, another thing is some implicit feedback, right? Like the user barge in a turn or rephrase her request. In this kind of scenario, some information actually happens. And we also have some unsolicited feedback, such as thank you, I'm not Derek, I'm Dave. This kind of answers also indicate some information regarding our generated response. So there are some work to do this kind of defect correction with like self-learning. So which means the signal actually comes from the conversation itself. This is why I'm using the term self-learning here. And also do a little bit of rephrase detection to get the signal from the corpus. And do a little bit of failure point isolation. Suppose we give the conversation how to detect those kind of failure points. Right? Sometimes the whole conversation fails, but it might be caused by some early error in the formal turn. It's not until the last turn. So how to detect those failure points. And also we can use like reinforcement learning for improve some long-term planning. Yeah, so yeah, a lot of things actually is worth to investigate. And if you want to get more information, we actually have a tutorial, and this is a link to our tutorial. Thanks.